We are officially on 3.3, and we're going to ask ourselves, where is a system located? And as we do that, we're going to answer the question, how do forces affect the motion of a system's center of mass? Our objectives: explain the significance of the center of mass, location of a system, be able to calculate the location of a two-object system's center of mass, calculate the velocity of a system's center of mass, determine what forces change the motion of a system's center of mass. Pages, yeah. Vocabulary preview. What is the center of mass? It's a special location for the system where the system would balance if it were set on a fulcrum. A fulcrum, you know what a fulcrum is. If you have ever been on a diving board, there's this little triangle-looking thing. And you can adjust that triangle-looking thing from here, or you can come around here. And this is the point where this diving board is going to rotate about. Or a seesaw. You've got one person on one end, another person on the other end, and you have this triangle-looking thing right in the middle of it. And if there is nobody in the middle of it, on a really good seesaw, the high-quality one, not the cheap imitations, I don't know if that's true, but you can get it to balance exactly flat. You can do this with anything, and that's what we're going to look at today. Car is set on a metric football field as shown. What is the position of the car? Metric football field. The NFL goes to London and they still use yards. Is it x equals 27 meters, the front of the car? Is it x equals 21 meters, the back of the car? Or maybe x equals 24 meters, the average of them both? This comes up a lot. If you've done an experiment where you have a car moving along, are you measuring everything from the front of the car? Are you measuring it from the center of the car, the back wheel? Where is it? For every object or system of objects, we can define a special location called the center of mass, abbreviated capital CM. Wherever the center of mass is, that is the position of the object or the system. Where is an object or system center of mass? It is where a fulcrum must be placed in order to balance the object or system on a light board. If the car were set on a light board and balanced on a fulcrum, the fulcrum would need to be placed here. Why there? That's definitely not the center, right? The actual car center of mass is a little closer to the front, putting it near the 25-meter mark. That's because the front of the car is slightly heavier because the engine is so massive. So in the back, you don't have this engine. If an object has a heavier end and a lighter end, the center of mass is closer to the heavier end. Even humans. Center of mass of a hammer is closer to the metal end because it is heavier. Center of mass for a human is within the chest, closer to the heavy end and farther from the lighter feet. So it's usually right about your belly button. For girls, it's usually a little bit lower. For a guy, there's used to be a challenge where if you stood with your backside flat against a wall and you had a normal chair with the seat part facing you, the challenge was keeping your butt against the wall, leaning over and picking up the chair. And you're not able to do it because your center of mass normally has to shift for you to come over. If you try this without a chair,